Hello. Today we're going to be talking about fractional exponents. Fractional exponents are a little different than regular exponents in that they look different. They may feel a little funny. Right. So as a reminder, regular exponents we might see something as written as y equals b to the x, where y is our base and x is our exponent. For some of my examples, I'll be doing x, where x is actually the base, and then m is our exponent. And so in this case, I want to explore 4 to the 3 halves. Now, before we explore this in depth, I want to look at that 3 halves a little bit more in depth. So 3 halves we can rewrite as 3 times 1 half. And that is going to help us as we explore different things. And so if I have 4 to the 3 halves, I can also rewrite this as 4 to the 3rd times 1 half. Well, an important part of fractional exponents is to try to remember different other properties of exponents, such as the power rule, product rule, quotient rule, zero product property. All these things can sometimes help us when we're dealing with fractional exponents. And so if you aren't familiar with those rules yet, I suggest you go to my other video on the rules of exponents and look at those and learn a little bit about them. But now that we have 4 to 3 times 1 half, using the power rule, I can rewrite this as 4 to the 3rd times 1 half. Now there's different things you may do to this. We can say, okay, well, what is 4 to the 3rd? Well, 4 to the 3rd, right? 4 times 4 times 4. Well, 4 times 4 is 16. And 16 times 4 is 64. So now we have this to be 64 to the 1 half. And what this does, when you have the 1 half or 1/3, that means you take the nth root of that. So because I have the 1 half, I'm going to take the second root, or just the square root, right? So you don't have to write that 2 there. I'm just doing it to kind of emphasize it. So the square root of 64 is 8. So so that's one thing to keep in mind is if you have x to the 1 over m, you can rewrite this as the m root of x. And so we're going to continue exploring this a little bit more, but let's get a little bit more room. And so once again, since it's off the screen now, looking at 4 to the power of 3 halves. And so let's rewrite this just a couple other ways. So we had 4, let's look at it, 4 to the 1 half times 3. Well, I can rewrite that as 4 to the 1 half times 3 using the power rule. Right? Well, 4 to the 1 half, it's just the square root of 4. To the 3rd power. And square root of 4 is 2, or this is 2 to the 3rd. And 2 times 2 times 2 we know to be 8. So just another way to look at what we are doing. And so let's look at different ways that we might be able to rewrite some of this stuff. So if I have x to the m divided by n, there's going to be a whole lot of ways I can rewrite this. I can rewrite this as x to the m times 1 over n, which is the same as x to the m to the 1nth. Or I can rewrite that as the nth root of x to the m. I can also rewrite this as x to the 1nth to the m, which I might be able to then rewrite as the nth root of x to the m. So as you can see, there is quite a bit of ways to rewrite this one equation to make these all equivalent. So we see that we have all these equivalent forms, and so when you're doing different problems, right, an important part is try to recognize that we can rewrite these into different forms, because as we rewrite, sometimes one form is going to be easier for us to work with than another, depending on the situation in which we are dealing with at the moment. And so the only thing to keep in mind in this is n cannot equal 0. Otherwise, you're trying to divide by 0, and we know that that is undefined, and so we can't do that. And of course, if we played around with this, you most likely would be able to come up with a couple more forms in which you could rewrite radical exponents or fractional exponents, right? So we're using radicals and a number of other things to do all of this. Hopefully that's a little introduction into fractional exponents, and hopefully it is something that will help you out. Best of luck in your studies.